Hey, good morning, everyone. It is 10:30, so let's go ahead and get started. We're all here today because we all love alerts when they're not blowing up our phones at 3 a.m. for no good reason, right? Today, I'm going to be speaking about how to make sure that your alerts don't become your team's worst enemy and instead become your best line of defense. Welcome to Document, Detect, and Defend, because life is too short for bad alerting strategies. What is my objective with today's briefing? My goal is to simply expose you to a simple strategy with a whole world of possibility. I'm going to try my best to get through this in as much time as I can in my 25 minutes. And hopefully at the end of the time, I will have time for questions, maybe one or two. We'll see. We'll also get some live audience participation here in about 15 slides. So before we dive in, let's talk about why good alerting strategies are a game changer. I don't know about your experience, but in my experience, historically, the amount of alert documentation has not been sufficient for the total amount of alerting that we triage as SecOps teams from day to day. It's like we create these rules and throw them out there and we cross our fingers, hoping that we're going to remember how they work 6 months from now. But nobody really likes to play detective in their own rule set. Historically, our alerts have not been validated for durability. Too often, we just push rules out without really testing them under hydraulic pressure. Unfortunately, our rules aren't even as durable as a Nokia 3310. You want rules that can survive the zombie apocalypse, or at least a security breach. Historically, our alerts aren't even really reviewed before they're just tossed into production. Because we're often firefighting or there's some other type of perceived urgency, we have a bad tendency to just throw rules into the SIM, into the platform without a second glance. No review, no validation, just straight into the wild. It's like hitting a send on an email before you've double-checked who is actually CC'd. Because testing in prod is totally a legitimate strategy, right? As a result of these three main issues, some really smart people over at Palantir put together a framework to help us counteract these issues. If you've never heard of Palantir, they're a really big deal in the big data world. They did $2.3 billion in revenue last year with a B. They make products that allow organizations to analyze big data sets and make decisions. And therefore, they have to have a pretty stellar security team. The framework that they created is called the ADS framework, which stands for Alerting and Detection Strategies. I always explicitly use the acronym ADS, and I don't say ads, because I'm not talking about those annoying little pop-up ads that follow you from desktop to phone. The content that I'll share today is my own, but I'm drawing on a lot of ideas from their blog post that outlines the framework. Speaking of me, my name is Brayden, and I come from a really diverse background in cybersecurity. I've worked for cloud-native SaaS, FedRAMP, compliance, and even in the managed security sector. Throughout my career, I've tackled the challenge of scaling security operations. I've built systems that deliver high-quality security services to hundreds of companies. Currently, I'm a senior security engineer, but I've also been a SecOps manager, so I know what it takes to strategically enhance the security posture of the organizations that I serve. So now that we know why all of this is important, let's decode this thing. What actually is the ADS framework and what is it all about? The ADS framework is a templated documentation exercise that you can use to thoroughly document, test the durability of, and review alerting and detection strategies through a formalized system. The template itself has a bunch of sections in it, like goal, categorization, strategy abstract, false positives, validation, priority, etc. It's a pretty big template. We're going to get to some screenshots and examples in a bit, but the template is just one part of the overall strategy here. There's another important component that contributes significantly to the strategy. In addition to the template, we also need somewhere to store our ADS entries, somewhere that's like centralized and version controlled, maybe something like GitHub. GitHub isn't just a code repository for developers and software engineers. It's actually a vital part of our alerting strategy. It's the foundation that allows our detection engineering to be agile, transparent, and scalable. Whether we're rolling out new rules or refining existing ones, GitHub gives us the ability to document, iterate, and improve with confidence, ensuring that our alerting strategy evolves alongside the evolving threat landscape. But a little more to come on GitHub later. When you combine the template with version control, that's when you've got a workable strategy. It works because within the life cycle of an ADS entry, we get three things. We get enough and appropriate documentation for the rule. We get validation logic to prove that the rule can actually detect what we want it to. And we get code reviews on the initial deployment of that rule, as well as any subsequent changes. And if you remember our three issues from the beginning, this solves all three. Personally, I learn best by doing, so let's build an ADS entry and make sure that every alert is worth your time. Now's the time for that audience participation. Will a brave soul, someone, call something out that you would like to alert and detect on?
Base 64 encoded PowerShell command.
Oh, I'm a little hard of hearing.
Base 64 encoded PowerShell command.
Base 64 encoded PowerShell command lines. This is a great thing to detect on. So we're going to start out with a goal, and I think this is big enough that we can see it on the back end. So the goal is basically the intended purpose of the alert, a description of like what we're trying to detect. So in our example, we're literally just trying to detect PowerShell commands that are being run via encoded base 64 encryption. That's a tough one. That's a mouthful. But that's basically what we're trying to detect. We're trying to detect PowerShell commands being obfuscated and run on a host. This is a good example. I like this. The next step in the ADS template would be a strategy abstract. A good research paper is nothing without a summarizing abstract. So the abstract is basically the high-level walkthrough of how the ADS will function. Essentially, what event or behavior or activity are we looking for? What are the data sources? Is that data being enriched, or do we need to pivot? So in the case of our example, we're probably going to want workstation logs as a data source. We might want even our EDR logs. The EDRs are pretty good at picking this up. And you might say, well, now we've got two data sources. Maybe what's a third, a fourth? What specific Windows event logs do we need to look for to determine that PowerShell is running? How do we identify that it's base 64 encoded? All of these things are summarized in the strategy abstract as a high-level walkthrough. Have you ever been burned by a false positive at 3 a.m? There's even a section for that. This section will kind of take into account the uniqueness of each environment. And this is a place to brainstorm false positives ahead of that 3 a.m. alert time. So in our example, there actually might be some legitimate running of base64 encoded PowerShell in our environment for whatever reason. It's a weird environment. Or, we might realize that sometimes non-base encoded PowerShell is being caught by our strategy, and we can note those oddities and idiosyncrasies of our own environment in this section. Validation are the steps that we can take to actually generate a true positive alert. This is the rules equivalent of a unit test in software development and is one of the most important sections in the template. We'll get to a little more on that later. But in our example, we might write down the steps here to say, yeah, go pull down this already base64 encoded PowerShell script and run it on a workstation. That should be enough to generate a true positive alert and validate the rule. There are a bunch more sections, but just for time's sake here, the last section I'll demo is the response. This becomes an area for you to document what the actual incident responder needs to do when they see this alert trigger. Because if the night shift analyst is responding to your alert and doesn't know what to do next, then you also become a night shift analyst. As you can start to imagine with a pretty flexible template, this is just the surface. I have a few extra tips to throw in there for you. One thing to consider is that this framework is open source. It's licensed under the MIT license. And so you can modify the base template from Palantir and add your own sections. For example, you might have more than one security tool that's doing alerting and detecting. So it might be helpful to document, this tool lives in Splunk, or this ADS lives in Sysdig or Elastic, or insert X platform or tool. Nice little spot to have some documentation. You might also have known exceptions or do not notify rules. When we tune these rules and we're adding exceptions, it might not always be clear why that exception got added in the first place. Maybe a client said, it's fine, we don't care about this. Maybe the security manager said, it's fine, we don't care about this. That's not always clear 6 months, a year down the road why there was an exception in place. This is a great spot to add to the template to document that for posterity. Additionally, we might document specific reasons why an alert doesn't actually send out a notification. So now that we've kind of started to compose an ADS entry, it's time to document and validate, because if it isn't documented, is it even real? Does it exist? I don't know. But before we talk about the overall life cycle of an ADS entry, I want to point out that on a macro level, this whole concept goes really well hand in hand with a popular upcoming idea of writing detection as code. There is a ton of great work being done here with the Sigma detection format and human readable YAML, which really makes understanding DevSecOps and basic development concepts that much more important for SecOps people. I've got links to Sigma and YAML and cybersecurity in the slide notes. So here's the life cycle of an ADS entry, as I envision it at least. It all starts out with an idea. Someone like an engineer, an analyst, a manager, a director, someone has an idea for something that they want to detect, and they say, this is something that we need to have a strategy around. At that point, an engineer is going to start to document and develop that alert. They're going to do all the things that detection engineers do really well. They're going to know what event logs relate to the activity. They build the condition and the logic, the queries to actually detect those events. And ideally, the engineer is also writing up an ADS entry at this time, and they're noting all the important aspects of the detection, filling out the sections. And then we get to the validation that I spoke to earlier. Now, validation matters because we want to ensure that we can capture a true positive of the activity. How many rules exist in your sim or your environment right now that have never actually triggered or alerted? And do you know which of those rules there are? In the rare case where we can't truly validate something, we ought to at least document in this section why we're not able to validate it. Maybe it's a really super rare edge case and we don't want to put strain on that system, or for whatever reason we can't validate it. But in the actual framework template itself, it says if you're unable to generate a true positive alert, the alert may need to be broken down, refactored, or entirely discarded. So we've got the template filled out, we've got the rule, we've got the logic, we've got the validation. Now it's time for a code, quote unquote, code review in GitHub. And this is a decision point. If everything is documented well, we're validated, it gets approved, that rule moves into prod, and we continue with the continuous improvement process. We're making adjustments, we're adding tunings, we're adding exceptions, all those things that we love to do in the sim. In the case that there's just not enough there for that rule, it might not be approved. We're able to make adjustments and loop back until it does get approved. So now we've got our ADS drafted, approved, it's been tested, it's durable, it's validated, and we are in prod. Don't set it and forget it. Let's actually track and improve the alerts. This continuous improvement cycle is very important. As our SecOps team gets bigger and starts to cover more geographical area, different time zones, different countries, maybe we've gone 24/7 and now have 3 shifts to manage. Maybe we're doing follow the sun. Whatever it is, it's always getting more and more complex, and it becomes harder and harder to communicate these small day-to-day changes out to the team. This is where the strategy of implementing the version control allows us to generate visible artifacts of the changes that anyone on the team can subscribe to and follow along with. This may be tough to see, but it's it's an actual screenshot of our ADS repo at my employer. And by opening a pull request, I can request that my team review the changes I'm making to the ADS entry, and we can make any adjustments that we want to before we merge that into prod. This process ensures that at least 2 sets of eyes, my set of eyes and your set of eyes, have at least seen the changes before they go into production. This idea could be matured and developed to only allow approvals from T3 analysts or engineers or team leads or management, but that's kind of the next step of maturity. Another good use case for this version control is documenting exceptions and tuning. I can't show company secrets of what we have excluded in our environment, but let's pretend that there is a situation where you are changing our rule logic to suppress notifications for a specific alert. It would be very important for everyone in the room and for me to know that this alert is no longer expected to send a notification. So you go ahead and you make that adjustment. You submit it via a GitHub pull request. It gets approved and merged to prod. And because my Slack notification channel is subscribed to that GitHub repo, I get to see that change happen in real time. And now everybody gets to see nearly every change that's being made as it is made. No more email blasts, no more weekly briefings to get everybody caught up to all the changes in the SIM. Everyone understands what's happening and everyone gets to feel really good about it. All right, wrapping it up before we all get alert fatigue. Today we talked about why we need a framework and what ADS is. We started to develop a live example of a base 64 encoded PowerShell script running and what that ADS entry might start to look like. And we reviewed the ADS lifecycle and benefit of source control. I hope that this is just the start for you and that you've caught my excitement for the framework. This is literally something you can start today. You can pull down the repo, you can start editing the template and doing your own documentation. Start today, start next week, start whenever. But the time that you invest will pay off, even if you just start with documenting critical and high alerts. Thanks for sticking with me through this rapid fire session. Your feedback means a lot to me. So if you scan this QR code, it'll put you through to a 1-question survey for some feedback, and then it'll pass you forward through to my slide deck. So you'll have access to the slides, all the links, all the references. Come chat with me in the back after. Happy to answer any additional questions. And go out there, build alerts that you can actually be proud of and that won't drive you crazy in the middle of the night. Thank you very much.
Yeah, I got a question if you got them.
Yeah, we do have about 3 minutes, I want to say. Or how are we on time?
Like second.
We got plenty of time then. What's your question?
So is this something that makes sense to kind of like share with your NDR providers? Because one of the things that, like every time we talk about it, is I don't know what framework or access to really give them, so let them to do stuff.
Sure.
That.
Sure. So the question is this something you can share with your MDR provider? And I think absolutely, coming from an MSSP background and knowing how specific certain clients can be, I think this would be a great start for them to document specifics for your environment and other clients' environments. In the MSSP space, there's a lot of sharing going on, sharing of the rule set, sharing of exceptions, sharing of threat intelligence. So that's a great question. Good opportunity to share with the MDR for sure.
That time.
Of course. Any other questions?
Well done.
Thank you.